What is the sum of the interior angles for a triangle? It's 180. We've talked about this already. What about for any quadrilateral? Okay, so those are the two that we've already talked about. Okay. When you get into, let's say, a pentagon, okay, one of the easiest ways in order to figure this out. So if you forget this and you're taking a quiz or a test or whatever, it's the same is true as on the standardized tests like SAT or ACT. If you don't remember what the formula is, easiest thing to do is just draw in a diagonal. Draw in all the diagonals you can from one vertex. So pick a vertex, doesn't matter where, and then draw in all the diagonals. And what you will see is how many triangles are formed in this shape now, in the quadrilateral. 2 triangles. Each triangle is 180 degrees, and so the total sum is 360. What about when you take a pentagon? Draw in all the diagonals that you can. So you connect all the non-consecutive vertices. Okay. How many triangles can you form here? 3. Each one is 180. And so that's going to give you a total of 540. And so you can always derive the sum of the interior angles using a diagram. And now keep in mind that that's not this. You can't just draw in all the diagonals and then try to count the figures, right? The reason you draw all the diagonals from just one vertex is when you look at these triangles, triangle 1, triangle 2, and triangle 3, the sum of all their angles actually form those interior angles of the polygon. Whereas here, if you're adding this angle, this angle, this angle, is this angle a part of any of their interior angles? No. So you just draw the diagonals from one vertex, count the number of triangles, multiply that by the sum of the angles in each triangle, and you'll get your total sum. Now, as you look at this, this fits the pattern 1 times 180. Okay, how does this number relate to the number of sides? So triangle has 3 sides. 3 minus what equals 1? 2. A quadrilateral has 4 sides. 4 minus what equals 2? A pentagon has 5 sides. 5 minus what equals 3? So it gives you this pattern. And the pattern is the sum of the interior angles. You're going to take the number of sides, n. You're going to subtract 2 from that. And then you're going to multiply it by 180. And that gives you the sum of the interior angles for any convex polygon. Okay, so we looked at it already with triangles. The sum of the exterior angles was 360. We looked at it and saw it in quadrilaterals. The exterior angles have a sum of 360. Okay, and if you looked at these here and we extended this out, okay, easy way to see this is how many linear pair of exterior angle and interior angles do you have in a pentagon? You have 1 at every vertex, right? So we have, in this case, 5 sets of 180. And how many of these sets of 180 account for the interior angles? The interior angles are formed by 3 of those sets of 180. So what's left for the total sum of the exterior angles? 2 sets of 180. If we look at the quadrilateral, here we have 4 sets of 180 when you're dealing with the interior angle and exterior angle pairs, the linear pairs. How many of those account for the interior angles? 2. So what's left? Bless you. Okay, so as you can see, this pattern will continue as well. So you're always going to have a sum of exterior angles of 360. You're always going to have a sum of interior angles of n minus 2 times 180.